All right, so last time we began something to do with components, and we just wanted to tell you that electricity was the flow of electrons. So every time your device is running, be it an electric kettle, be it a TV, just know electrons are flowing, and that's how you're able to get whatever you're getting: water boiling, TV showing pictures. So current is flowing, and usually for current flow there should be something providing the energy to cause the current to flow. So you know that electrons are actually what flows, that is almost a given. That's electricity. So when electrons flow, basically work gets done, and that work may be realized in form of you boiling water, in the form of you seeing pictures, in the form of you feeling wind from a fan. That's because electrons are flowing. Now for them to flow, we know that something has to provide work. In other words, there has to be a potential difference. In other words, electrons have to flow from one point to another, from one place with a high potential difference to another. This potential difference at times is synonymous to what we call voltage. So the sources of this voltage usually include things such as your battery, if the thing is battery powered, right? Like for instance, a radio. It can be from your electricity mains, that's like your power grid, from your socket. Yeah, so those are like sources of the energy that causes this electron to flow. And like we said earlier, if we had a wire, you notice that this wire is made up of atoms which have actually electrons. So whenever you put a potential difference, normally the place of higher potential difference is indicated with positive, and then the place of lower potential difference is indicated with negative. Therefore, we shall have electrons flow, and therefore work will be done. So you just imagine it the way you would see a slope. At the top of a slope there's high potential energy, and then at the bottom there is low potential energy. Yeah, so this thing will easily roll down to the bottom, and that's the same thing with electrons, current. Current will normally flow from places of high potential difference to places of low potential difference. So that's the direction in which our current would actually flow. Anyway, I am recapping this so that when we go to the next step, I find it easy for you to understand these concepts. Now, having said that, I need to introduce you to another thing, and that is something to do with the ease of flow of electrons. Yeah, how easily electrons flow in something is measured by the resistance of that something. Like the ability of this something to resist the flow of electrons is called resistance. Yeah, so that's where you'll get words such as resistors. But let me just give you a small example. Now, you consider yourself as though you were an electron. So assuming you are an electron, by that I mean you, Nathan, you are an electron. If the ground is flat, it will be very easy for you to walk. Now, if the ground was sloping, you will find more problem moving from point 1 to 2, because this ground is inclined. Now if the ground is vertical, yeah, and I want you to move from point 1 to 2, this is very hard. In fact, we could say this is impossible. This one is easy, this one is hard, and this is almost impossible. Yeah, so now this is an electron that we are representing by a person, and this is also an electron, this is also an electron, and this guy has to go up there, this guy also has to go up. So it's much easier for an electron to move on a flat ground, or sorry, a person to move on flat ground. And now if I am to use an analogy, like a comparison in real life, this flat ground is what we will call a conductor. A conductor. In conductors, it's very easy for electrons to flow. Now conductors are simply, I don't know whether you're still seeing me in frame. Let me write this in green. This is flat ground would be a conductor for electrons case. Like it's very easy for an electron to flow through a conductor. And I was telling you that conductors, the easy way of understanding them is just like pure metal. Any piece of metal is a good conductor. You could have an example of copper, you can have an example of aluminium, you can have an example of lead, you can have an example of iron, and all these are metals, and these are almost like the way you would see flat ground to a person walking. You can easily walk on flat ground. That means also here electrons can easily flow through conductors. Now where it is hard, this is a slope. That was flat ground, and this was steep or vertical. Just like it is slightly harder for you to walk up a slope, now for electrons, they also find it slightly hard to move through what we call semiconductors. Yeah, and then it is impossible for electrons to move through what we would call insulators. Insulators. Now I have mentioned insulators before in the previous videos, and I am going to list them before I can list semiconductors. Now insulators, these clearly electrons don't flow through them. Now this is the way you would see plastic, rubber, yeah, wood, yeah, paper, and so on and so forth. As long as it is not metal, electricity will have trouble flowing through it. Now the semiconductor lies in between the two. Yeah, it lies in between there, meaning that it allows electrons to flow through it, but not very well. They do it with a lot of struggle, just like how it's a bit disturbing to walk up a slope. And these are, if you've done some chemistry, these are usually group 4 elements. Elements in group 4. The example would be carbon, like the way you see in your pencil nib or charcoal. You'll have silicon, I believe also germanium. These are all group 4 elements. So they have a behavior that is in between conductors and insulators. So they will allow current to flow, but not as quickly as they would do in conductors. They will stop current, they will slow down the flow of current or electrons, but not as much as in insulators, which completely stop the flow of electrons. And I think having taught you that, I believe I should introduce you to the concept of resistance. And you know that we have mentioned that resistance is the ability of any material to stop or oppose the flow of electrons. So that means if you have a conductor has a very low resistance because it has a very low ability to resist the flow of electrons. A semiconductor has a relatively higher resistance than a conductor because it makes it a little harder for electrons to flow through it. It kind of has a lower resistance to flow. Okay, it has its resistance to flow of electrons is slightly higher than that of conductor. However, it is not as effective as insulators at stopping or opposing the flow of electrons. So that's why I needed to first introduce you to what electricity is, which it is the flow of electrons, and then what resistance is, which is the opposition to the flow of electrons. I think, should I stop there or I continue? Okay, Nathan says I continue. So he's using gestures instead of saying yes. It's also part of this video. Now, okay, so I have mentioned resistance. I think at this point you should be able to understand resistance. Just the way I just told you that how steep a slope is shows you how hard it is for you to climb it or walk on it. Flat, less resistance. Gentle, more resistance. Steep, extreme resistance. Vertical, almost impossible to walk on. Yeah, it's actually impossible to walk in a vertical direction. I have not seen anyone do it. So that analogy we had given you earlier will help you with that. Now, having talked about resistance being the opposition, from the word oppose, not your political opposition, opposition to the flow of electrons. Yeah, or you could say opposition to it, but this is the better definition. Let me not confuse you. Opposition to the flow of electrons, and we know that yeah, what should I say now? The next thing that I wanted to tell you is, remember I had told you earlier that for electrons to flow we need a source of energy or a potential difference, which is voltage, and we could call it as V. Yeah, and then we said electricity is the flow of electrons, and that's, we tend to call it current. When electrons flow, that's current, and current has the symbol A, voltage symbol V. And then I think this far you have also had the word resistance, which is R. Oh, my bad, this is actually a unit of current. The symbol is I. Pardon me. Yeah, R. Okay, and then resistance, the symbol is R. Now I want to now tell you that the units for voltage is actually volts, denoted by V. The units for current is denoted by A, which is amperes. Okay, let me write this in full. Volts, which is given the symbol V, amperes, is given symbol A, capital A. And then the value or symbol for resistance is ohms, which is written like your headphones, but that's how they write ohms in Greek. It's actually a Greek character, I think. Now, having said that, because we are supplying a voltage or a potential difference to provide the energy that will cause current to flow, and this current as it is flowing is being opposed by the resistance. Therefore, there is a relationship. Yeah, if you're a mathematician, there's a relationship between the above. So I don't know whether I write for you the entire relationship or I just give you how they relate. Huh? I'm not going to draw a triangle. So I'm just going to tell you, the higher the voltage, the higher the current that will flow. So in that case, we say there's a direct proportionality between current. Pardon me, I find myself writing the symbol, so the symbol of the units instead of. There's a direct relationship. In other words, when we say there's direct proportionality, we mean that when voltage increases, you expect the current to increase. In other words, when you provide more energy to push electrons, that means more electrons will actually run or flow. So voltage is directly proportional to current. Now, the other thing also that you should know is that current, yeah, because current is being resisted, it will therefore be inversely proportional to resistance. That means the higher the resistance, the lower the current that flows. And if the current flowing is higher, that means the resistance is lower. Anyway, I hope I haven't confused you, but what I'm driving at is that eventually when you manipulate that relationship, we have voltage equaling to current multiplied by resistance. So that means if this rises and that rises, to keep this constant, this has to come down. Okay, anyway, that's it for today. I think I've reached the point where I may confuse you. Let me stop at that, and we shall begin from there the next time. See you in the next video.